There is a truck in China that drives up to a pothole on a highway, stops briefly, and fixes it. Not patches it. Not throws some gravel in the hole and moves on. Fixes it. The machine cuts out the damaged section of asphalt, vacuums the debris, fills the cavity with fresh hot material, compacts it smooth, and drives away. The repair is level with the surrounding road surface. The entire process takes minutes, not hours, not days, not the 3 weeks your city takes to get around to filling the crater you've been swerving around since last winter. Minutes. And by the time the next car reaches the spot, the pothole is gone. If that sounds too simple, it's because you have been conditioned by decades of watching road repair happen the hard way. In most countries, including the United States, the United Kingdom, Canada, and across Europe, fixing a pothole on a highway is an event. It is not a quick task. It is a production. It starts with someone reporting the damage. That report enters a system. The system assigns a priority level. The priority level determines when a crew will be dispatched. Days pass, sometimes weeks. When the crew finally arrives, they set up a lane closure. Out come the orange cones. Out come the arrow boards. Out come the barricades. Traffic is diverted or squeezed into fewer lanes. The crew marks the damaged area, cuts around it with a saw, removes the broken asphalt, cleans the hole, applies a tack coat, fills it with new material, compacts it with a roller or a hand tamper, and removes the lane closure. The repair itself might take 30 minutes to an hour per pothole, depending on the size. But the setup, the closure, the traffic management, and the teardown can stretch the total disruption to several hours. And during all of that time, traffic is backed up, drivers are frustrated, and the maintenance crew is standing in a live highway environment hoping nobody drifts into the work zone. Now multiply that by the scale of the problem. In the United States alone, AAA estimates that pothole damage costs American drivers roughly $3 billion per year in vehicle repairs, tires, wheels, suspension components, alignment. That number does not include the economic cost of traffic delays caused by pothole-related lane closures or accidents. It does not include the cost of the repair crews themselves. It does not include the lawsuits filed against cities and states for vehicle damage caused by roads that should have been maintained but weren't. Potholes are one of the most expensive, most universal, and least glamorous infrastructure problems in the world. Every country has them. Every driver hates them. And almost nobody has changed the fundamental method of fixing them in 50 years. China looked at that method and decided it was too slow. But before we talk about what China built, it helps to understand what a pothole actually is. Because most people think of a pothole as a hole in the road. It is not. It is a failure cascade. It starts with a crack. Water from rain or snowmelt seeps into the crack and reaches the base layer beneath the asphalt surface. In climates where temperatures drop below freezing, that water expands as it turns to ice. The expanding ice pushes the asphalt upward from below, widening the crack. When the temperature rises, the ice melts, leaving a void, a small, empty space beneath the surface. Traffic rolls over that weakened section. The weight of each vehicle compresses the unsupported asphalt downward into the void. Eventually, the surface collapses. That is a pothole. And once it forms, it gets worse with every vehicle that hits it. The edges crumble. The hole widens. Water fills it again. The cycle repeats. A pothole that is 1 foot wide in January is 3 feet wide by March if nobody fixes it. The damage to vehicles is not minor. Hitting a pothole at highway speed can blow a tire instantly. It can bend a wheel rim. It can crack a suspension component. It can knock a vehicle's alignment out of specification, causing uneven tire where that costs hundreds of dollars to correct. At lower speeds in urban areas, the damage is usually less dramatic but cumulative. Repeated impacts over months degrade suspension bushings, wheel bearings, and steering components. The drivers who are affected most are the ones who can least afford it. People driving older vehicles on daily commutes through poorly maintained urban roads. The pothole is not just an inconvenience. It is a regressive tax on people who drive through neighborhoods that don't get fixed first. To understand why China cares about pothole repair speed more than most countries, you need to understand the scale of what they are maintaining. China operates over 180,000 kilometers of expressway, the largest high-speed road network on Earth. Behind that are millions of additional kilometers of national highways, provincial roads, and urban streets. The total maintained road surface in China is staggering. and every kilometer of it is subject to the same forces that create potholes everywhere: water infiltration, freeze-thaw cycles, heavy vehicle loading, thermal expansion and contraction, and the simple wear of millions of tires rolling over the same surface day after day. At that scale, dispatching a traditional crew with cones and aero boards to each individual pothole is not just slow. It is functionally impossible. You cannot maintain 180,000 kilometers of expressway using a method designed for a Tulane County road. The math doesn't work. You would need an army of crews operating simultaneously across the entire country, each one setting up and tearing down lane closures for every individual repair. The traffic disruption alone would create more economic damage than the potholes themselves. China needed a method that was faster, required fewer people, caused less disruption, and could scale across the largest road network in history. The answer was to put the entire repair operation inside a single vehicle. Chinese road equipment manufacturers, companies like XCMG, Sany, and others, developed integrated pothole repair trucks that carry every component of the repair process on board. These are not small vehicles. They are heavy-duty trucks with specialized equipment modules mounted on the chassis. A typical unit carries a high-pressure air system for cleaning the pothole cavity, an onboard hot asphalt storage and mixing system that keeps repair material at the correct temperature during transit, a cutting or milling system that can trim the edges of the damaged area to create clean vertical walls for better adhesion, a filling system that deposits the material into the prepared cavity, and a compaction system, usually a hydraulic plate or roller, that presses the fresh material flush with the surrounding road surface. The operator drives the truck to the pothole location. The machine positions itself over the damage. The cutting system trims the perimeter. The air system blasts out loose debris, dust, and water. The filling system deposits hot asphalt into the clean cavity. The compaction system presses it down. The truck drives to the next pothole. One vehicle, one operator, one continuous process. No separate cutting crew. No separate filling crew. No separate compaction crew. No cones laid out a quarter mile in advance. No aero boards. No 30-minute setup before the actual repair begins. The time savings are significant. According to manufacturer specifications and Chinese state media coverage, some of these machines can complete a single standard-sized pothole repair in as little as 5 to 8 minutes from arrival to departure. Larger or deeper damage takes longer. Complex repairs involving base layer failure may require traditional methods. But for the routine surface-level potholes that make up the majority of road damage on an expressway, the kind that forms when water gets under the surface layer and breaks it apart, the integrated truck handles them at a pace that traditional crews cannot match. But let's be precise about what is happening during those minutes. Because this is not a magic wand. The machine is not scanning the road and automatically finding potholes as it drives. In most current deployments, the potholes are identified through regular road inspections, patrol vehicles, cameras, driver reports, or increasingly, AI-assisted road surface monitoring systems. The repair truck is dispatched to known locations. It drives to the site, positions itself, performs the repair, and moves on. The automation is in the repair process, not in the detection process. Some newer systems are integrating road scanning technology that can identify surface damage while the truck is in transit, but that capability is not universal across all deployed units. The machine also does not eliminate all traffic disruption. The truck still needs to stop at the repair site. While it is stopped, the lane is partially or fully blocked. In some configurations, a brief traffic management setup, a following vehicle with warning lights, accompanies the repair truck. The disruption is dramatically shorter than a traditional lane closure, minutes instead of hours, but it is not zero. A vehicle stopped on a highway is still a hazard, and surrounding traffic still needs to adjust. And the quality question matters. A pothole repair is only as good as the material and the preparation. Traditional hand-done repairs, when performed correctly by experienced crews, can produce extremely durable patches because the crew has time to properly prepare the surface, apply bonding agents, and compact the material thoroughly. Machine-applied repairs at speed face a trade-off. The faster the process, the less time for each step. If the cavity is not properly cleaned, the new material won't bond. If the material temperature is slightly off, the patch won't cure correctly. If the compaction pressure is insufficient, the patch will crack under traffic loading. The manufacturers claim their systems handle all of these variables automatically. Independent long-term performance data comparing machine-repaired potholes to crew-repaired potholes is limited. The machines are relatively new, and the kind of multi-year durability testing that road engineers rely on takes years to produce. There is also a weather limitation that matters. Hot asphalt repairs work best in warm, dry conditions. The material needs to be placed at the correct temperature, and it needs time to bond with the surrounding surface. In cold weather, below about 5 degrees Celsius, the repair material cools too quickly, the bonding is weaker, and the patch is more likely to fail under traffic loading. In rain, standing water in the pothole cavity prevents proper adhesion. Most integrated repair trucks can blow water out of the cavity with compressed air, but heavy rain during the repair process still compromises quality. This means the machines are most effective during the warmer, drier months, which is also when roads are under the heaviest traffic loads and potholes cause the most damage. In winter conditions, when freeze-thaw cycles are actively creating new potholes, the machines face the toughest working conditions at exactly the time when the demand is highest. Some operators use cold-mix asphalt for winter repairs, but cold-mix patches are generally less durable than hot-mix and are often considered temporary until proper hot-mix repairs can be done in warmer weather. And there is a scale limitation to what the machine can fix. These integrated trucks are designed for surface-level pothole repair, cavities that extend through the top layer of asphalt but do not involve failure of the base layer or subgrade beneath. When the base layer itself has collapsed, when the damage goes deeper than just the surface, the integrated machine cannot fix it. That kind of repair requires excavation, base layer reconstruction, and full-depth patching, which still needs a traditional crew with heavy equipment. The integrated truck handles the majority of common potholes. It does not replace the entire road repair ecosystem. Now here is where the American comparison becomes relevant. And just like the road sweeper, this is not a story about American engineers being less capable. It is a story about systems. The United States has the engineering talent and the manufacturing capability to build similar machines. American companies like Simline, Bergkamp, and others already produce road maintenance equipment. Some American cities and states have experimented with faster pothole repair methods, including spray injection patching systems that can fill potholes in minutes. The technology exists in various forms, but deployment at scale faces the same structural barriers that held back the high-speed road sweeper. Highway maintenance in America is managed by 50 separate state departments of transportation, plus thousands of county and municipal road departments. Each has its own budget, procurement process, equipment standards, and vendor relationships. Most road repair is contracted out to private paving companies that use traditional methods because that is what their contracts specify and their crews are trained to do. To understand how deep that inertia runs, consider how a new piece of equipment enters an American state DOT's fleet. First, someone within the department has to propose it. That proposal needs to include a cost-benefit analysis, performance specifications, and a justification for why the current method is insufficient. The proposal goes through internal review. If approved, it enters a procurement process that may require competitive bidding, vendor demonstrations, and a pilot program lasting months or years. If the pilot succeeds, the equipment can be purchased, but only within the department's capital budget cycle, which is typically set years in advance. The entire process from initial proposal to operational deployment can take 3 to 5 years in a well-functioning state DOT. In a slow one, longer. Now imagine doing that across 50 states, each with a different process, a different budget timeline, and a different political environment. The machine exists. The technology works. But the system was not built to adopt things quickly. Changing the method means changing the contract. Changing the contract means changing the procurement process. And that means years of institutional movement before a single machine touches a single pothole. And there is a workforce dimension. Traditional pothole repair employs crews, flaggers, machine operators, laborers, supervisors. An integrated machine that does the same work with one operator threatens those jobs. In a country where road construction and maintenance employment is politically significant, especially in rural districts, the efficiency argument runs into the employment argument. China's centralized system can prioritize speed and efficiency over employment protection in ways that democratic, decentralized systems often cannot. There is also the contractor relationship factor. In many American states, road maintenance is a significant source of revenue for private paving companies. These companies have long-standing relationships with state DOTs. Their business model is built around crew-based repair methods that bill by the hour, by the crew member, and by the tonnage of material used. An integrated machine that does the same work faster with fewer people disrupts that business model. The resistance is not ideological. It is economic. The companies that would sell the machines are not the same companies that currently hold the repair contracts. None of that means integrated pothole repair machines will never appear on American highways. It means the adoption path is slow and fragmented. Some progressive state DOTs will pilot them. Some will publish results. Others will watch. The process will take years, possibly decades, to reach nationwide deployment. In the meantime, American drivers will continue to swerve around potholes that have been reported, logged, prioritized, scheduled, and still not fixed. But here is what makes China's approach genuinely worth studying regardless of where you live. Potholes are not an interesting topic. Nobody gets excited about road surface maintenance. There is no viral video of a pothole being fixed that gets 100 million views. Nobody is building a brand around asphalt repair. And that is exactly why it matters. The most important infrastructure work is the invisible kind. The maintenance that nobody notices until it doesn't happen. The repair that nobody celebrates until the road falls apart. China is treating road maintenance as an engineering problem worthy of the same innovation that other countries reserve for fighter jets and smartphones. They are building purpose-designed machines, deploying them at scale, and integrating them into a national maintenance strategy because they concluded that the traditional method does not work at their volume. Whether those machines perform as well as the manufacturers claim over 5, 10, or 20 years of real-world use remains to be proven. Whether the fast repair approach produces patches as durable as traditional crew-based methods requires data that does not yet exist in sufficient quantity. Whether the cost savings at scale justify the investment in specialized equipment is a financial question each network operator will need to answer for themselves. But the concept is sound. A single vehicle that carries every tool needed to detect, prepare, fill, and compact a road repair, operated by one person, completing the job in minutes rather than hours, and moving to the next location without a separate setup and teardown cycle. That is not science fiction. That is a truck. It exists. It is operating on Chinese highways right now. And the pothole it just fixed will be driven over by 1,000 cars today, and none of them will even know it was there. The next time you hit a pothole on your commute, the one that has been there since February, the one that has a cone next to it that fell over 2 weeks ago, the one that you report on the city's website and get an automated reply saying it has been logged. Remember that somewhere in China, a truck just rolled up to the same kind of hole, fixed it in minutes, and drove away. The road is smooth. The traffic never stopped. And nobody needed to put out a single orange cone. $3 billion in vehicle damage every year in the United States. That is not a pothole problem. That is a method problem. And one country decided to solve it with a truck.